Alright, welcome to the video for lesson number 16, what if there is a remainder? So if there's a remainder, we can find it by either doing long division or we could do it using the reverse tabular method. It really doesn't matter to me which method you are choosing to use, so I'm going to kind of do both throughout this video. Notice one thing right away. In the instructions it says create an equivalent expression in the form of q of x plus r of x over b of x. So this is quotient, this is the remainder, and b of x is the divisor. So sometimes questions, especially on like the Regents exam, they'll give you something like that. It really doesn't mean anything other than do the division, right? So let's take a look at the first one. The first one I'm going to do with the reverse tabular method. Again, if you're a long divider person, just do long division. Essentially, just see, do you get the same remainder as me? If you get a different remainder, look for your mistake. It's probably a sign mistake. So if I put x cubed in that first box, I know this has to be x squared, which tells us I need 3 columns. This becomes 2x squared. I don't want 2x squared, I want 7x squared. So I have to add 5 to 2, so that makes this 5x. Which makes this box 10x. Well, I don't want 10x, I want 14x, so I'm going to add 4, which makes this 8. Now, with the reverse tabular method, I already know the answer, or the quotient, is x squared plus 5x plus 4. Now I need to figure out what the remainder is. So for the remainder, I'm saying, what do I have to add to this number to make 3? Well, since it's going backwards, I know it's subtraction. So I'm going to add negative 5. So my answer is going to be minus 5, that's the remainder, divided by the original divider, x plus 2. That's my final answer. Alright, for the second one I'm going to do long division. So what I'm dividing by goes on the outside. What I'm trying to divide goes on the inside. When we did this in class, remember we used color to show what I'm subtracting or adding. What do I multiply by 2x to make 2x squared? Well, that's just x. That gives me 2x squared plus 3x. Now I am subtracting that second line, so this becomes minus and this becomes a minus sign, allowing me to cancel these, and this becomes negative 16x minus 10. I have to multiply negative 8 times 2 to make negative 16, so that's negative 16x minus 24. Again, I'm subtracting the second line, so this becomes a plus, and this becomes a plus, allowing me to cancel the 16s, and leaving me with 14. So my answer for that second one is x minus 8 plus 14 over 2x plus 3. For the next one, if you understood what I was doing in the exercises when we did the inspection method, you should be able to use inspection here. So essentially for inspection, I'm saying I'm going to change this to x plus 1 and then add whatever I want to add to 1 to make back negative 2. So negative 3. 1 minus 3 makes negative 2. I didn't change anything. If I understand what we're doing then with the fractions, I can separate that to two different fractions, x plus 1 over x plus 1 minus 3 over x plus 1, which reduces to 1 minus 3 over x plus 1. So that's my final answer. Now, if you're not an inspection person, don't worry about that. We can totally do this another way. We can still do long division. So I can say x plus 1 divided by x minus 2. So if I plug in 1, I get x plus 1. I'm subtracting, so these become subtraction. The x's cancel, and I'm left with minus 3. That's the remainder. So your answer is 1 minus 3 over x plus 1. It's the same answer either way. It doesn't matter how you do it. I like inspection just because it's quick and easy. If you want to do long division, it's really not that much longer. Let's look at the next one. For the next one, I'm going to do the reverse tabular method again. So I did see a decent amount of you in class were still using that, which is totally fine. However you want to do it works for me. 9x cubed goes in the first box, which makes this 9x squared, which then tells me I have 3 columns, because I need a column for x and a column for the number without x. Well, if that's 9x squared, this becomes negative 18x squared. These two have to add up to negative 12x squared, so I'd add 6x squared, because 6 and negative 18 makes negative 12. Making this middle term 6x, negative 12x, but I don't want any x's. Notice there's no x term here. So I'm going to put in a 12x because 12 and negative 12 makes 0x. Making this 12 and this negative 24. Then I have to ask myself, what do I add to negative 24 to make 4? Well, I have to add 28. So if I add 28 to that, I then have to rewrite my answer with a remainder. So my answer is going to become 9x squared plus 6x plus 12 plus 28 over x minus 2. There's my answer. All right, let's look at the last one, because this leads us actually into the next lesson. So if I divide p of x by x minus 1, do this one with long division, I'll make that x squared, which makes this x squared minus x squared, minus and plus. These cancel, that gives me 3x squared plus 2x plus 3x, that makes 3x squared. Minus and plus, we're getting there. 5x minus 5 plus 5. 5x minus 5. We haven't seen one like that all day. This comes out to be a remainder of 0, which is how everything was in those first few lessons. So if we have a remainder of 0, maybe that tells us something. Let's see. If I evaluate p of 1, I have 1 cubed plus 2 times 1 squared plus 2 times 1 minus 5. Well, p of 1 equals 0, meaning x minus 1 is a factor. So what we can say is if the remainder is 0, then the divisor is a factor. That's exactly what we're going to do in the next lesson. It's something called the remainder theorem. Hopefully this video helps. If you're struggling, remember, look back at your notes, look back at the other videos. I'll be after school this upcoming week. You have a test on Thursday. Yay, I know you're excited. Have a great weekend.